My name is Tripp Taylor. I'm the Chief Engineer here at Good Hope High School of Good Hope Inspires. We will be talking today about our science objectives. So this is our potential science objectives. This includes a cryovolcano on Saturn's moon Titan, the storms of Titan, and a lake Kraken Mare on Titan. Kraken Mare is made up of methane, and we will be measuring the composition, the temperature, and depth to look for the building blocks of life. The storms will measure the wind speeds and different things. And the cryovolcanoes will see how the lava on Titan compares to the lava here on Earth by its composition. Next slide. So this is our science objective trade study. UAH gave us figures of merit of 1, 3, and 9. Between interest of the team, how it applies to other science fields, and ramification of the answer, how easy it is to get the answer. We decided that through all this, after the weights and total scores, Kraken Mare was our winner with a total score of 222. Next slide. So this is our science objective chosen. Our science objective chosen was Kraken Mare. It's the chemical composition. We will study the chemical composition, the pressure, the temperature, and location of the payload. Kraken Mare is a massive lake of liquid methane. Next slide. So this is our science traceability matrix. Kraken Mare, how easy it is to measure, what we're going to measure, the measurement requirement, and what we selected to measure. So for example, we're going to measure the temperature, continuous samples at different locations, and we're going to use the thermocouple to take these measurements. Next slide. So this slide is our instrument requirements. So for each instrument we chose, we had to come up with the power, data rate, dimension, lifetime, and the frequency and duration. So for example, we talked about temperature and the thermocouple. It will have a mass of 0.2 kilograms. No power, or power is not available at this time. Data rate of 1.0 times 10 to the negative 4. Dimensions have not been determined yet. A lifetime of 1 hour with a continuous frequency for one duration. Next slide. So this is the support equipment requirements. So things that, those were our main instruments, and now what do we need to support those so they can all work together? For example, the onboard computer, the transceiver, antenna, and batteries. We have to do the same things that we did with the others. So we take the mass, the power, the data rate, the dimensions, and other technical specifications. For example, in the onboard computer, it has a 2 megabyte memory size. Next slide. So this is our payload design requirements, the project and the functional requirements. Most of the science objective away from the lake lander. The mass has got to be less than 10 kilograms, and the volume is 44 centimeters by 24 by 28 centimeters. How functional is this? So it will deploy, take measurements, collect data, provide power, send data, and house the payload. And one of the main things is it has to have no harm to the UAH spacecraft. Next slide. This is our payload destination, which like I said, is Kraken Mare with a composition of liquid methane. Its length is about 1,200 kilometers with a depth of around 160 meters with an area of 400,000 kilometers. It's larger than the Caspian Sea and northern hemisphere of Titan is where it's at. We'll be looking at all these different environmental challenges. For example, gravity and chemistry is one. The gravity there is 1.35 meters per second squared. And like I said, the chemistry, it is liquid methane, so it's not water like we see here on Earth. Next